Okay, guys, so hopefully you did really well on the quiz. This is supposed to be getting you ready for your common assessment that you have in math class tomorrow. So let's take a look. So number 1, it says Brendan finished a 5-mile race in 32 minutes. How long did it take him on average to run each mile? So what type of problem is this? We should all know it's a unit rate problem. And with a unit rate problem, we know we need to set up a word ratio, right? And use a proportion. So 5 miles in 32 minutes. And then how long for each mile? So if you say each mile, how many miles are you talking about? 1, right? Okay. So what 2 units are we dealing with? We're dealing with miles and minutes. So it doesn't matter which one's on top or the bottom as long as you're consistent. So if it says 5 miles in 32 minutes, where's miles go? On top. 32 minutes. And we're asking how long for each mile. So we know that we want 1 mile, but we don't know how long it's going to take. All right, so, oops. Once our proportion is set, what do we do next? Cross product, right? And I always do the one with the variable first. So I have 5x equals 1 times 32. So 32. Then we need to get the variable by itself. So I'm going to get rid of the number next to it by dividing by 5. So let's go down here and do our division. 32 divided by 5. 5 times 6 is 30. 2, put a decimal and a 0. 20. 5 times 4 is 20. So 6.4. And x was on the bottom, so it's minutes. 6.4 minutes. So our answer here was B. So guys, my expectation is that you're writing all of these steps if you don't have them on your paper. Even if you got lucky and circled the right answer, you should be correcting all of this in red pen. Only red pen. I'm grading based on that. So make sure that you have all of this work. So press pause if you need to. Get it all on your paper. There's no reason for you not to get this on there. All right, moving on to number 2. Diagram below shows a table of a table of values, x and y. Which equation represents the relationship between x and y shown in the table above? So we should be able to know when a table and stuff, we're looking at a constant rate of change or a constant of proportionality problem. So with those, we're going to go ahead and use our formula y equals kx. And to find k, we need to do k equals y over x. Okay, so looking at my formula and knowing that it's y equals kx, does this look like my formula here with a, x equals 3y? No, so I'm going to eliminate that. Y equals 3x, that could make sense. X equals 1.25y, nope, that doesn't look like my formula. Y equals 1.25x. Okay, so now I have a 50-50 chance. So then one option would be to try to plug in x values. So it's saying 3 times x is going to give you y. So it's saying essentially 3 times, let's say, 12 equals 15. Well, is that true? No. So I already know what my answer is, right? But I'm going to go ahead and make sure because I need to practice finding constants. So k equals y over x. And it doesn't matter which one I do. I could do 50 over 40. I can do 15 over 12. So I can do 15 over 12. Or I like 50 over 40. Or you could do 25 over 20. Either way, I'm going to go ahead and divide 50 over 40. Goes in one time, 40. subtract 10.00. 40 goes into 100 twice. Get 80, subtract 20, bring down a 0. So 40 times 5 is 200. So I have 1.25. So my constant is 1.25. So I'm just going to fill that in for my k. So y equals 1.25x. And there I see it right there for D. All right, make sure you have all this work on your paper. I should see the division and everything. Okay, moving along to number 3. Millie drives at a constant rate of 70 miles per hour. Which table shows the distance she can travel in different amounts of time? So first I need to make sure I write a table. Guys, every constant problem, essentially, we need a table. So I'm going to make x and y. And I'm going to go ahead and write the relationship. So I know it's a constant rate of 70 miles per hour. So per hour means how many? 1 hour, right? So 1 hour, she goes 70. 2 hours, how many does she go? Well, 70 times 2 is 140. Because they're saying our constant is k, right? 70 over 1, or 70. So then 3 hours, 70 times 3 is 21, so 210. 4 hours is 280. All right, so now that I have this, I'm going to go ahead and find my table. So 170 miles, that's right. 2 at 210. Well, 2, I should have 140. So that's not right. So I'm going to cross that one out. All right, this one here, it says 1 and 70, that's right. And then 140, well, that's next on my graph too, or on my table too, but they skipped up to 3. Not right. Okay, 1 and 70, going good. 3 and 210, that looks good. I didn't go further than that. So let me go down and look at the bottom. So I have 70 up top, that's right. But it says for 2 hours, is that right? No, we have 1, because it's 70 per hour. So there we go. We should definitely have our table and our constant on our paper. And let's go ahead and write the equation just to practice. So y equals 70x. Okay, so number 4. An airplane flies at a constant rate and travels 1,710 miles in 3 hours. Which graph shows the number of miles that they will fly at the same rate in different hours? The same rate in different hours. Okay, so we went 1,700 in 3 hours. So again, table every time. All right, so we're talking about 3 hours and 1,710 miles. All right, so I want to go ahead and find my constant. So I know k equals y over x, so 1,710 over 3. I'm going to do my division. 3 times 5 is 15. 21, so 3 times 7 is 21. I get a 0, but I need to fill into my decimal. So it's 570. Oops. So 570 is my k. Now, if I need to get my x, my y value, that's meaning that it's over 1, right? So x is 1, y is 570 as my constant. Let's practice writing our equation, guys. So y equals your constant, 570, x. Good. So let's look at this. So as the number of hours increases, the miles is increasing, right? So is this showing an increasing relationship? No. Is this one showing an increasing relationship? As time goes, it's going less distance. Well, that's not what the problem's explaining. So I'm already down to 2 graphs. Well, now I want to go ahead and check my coordinates on my graph. So the first one is 1 and 570. So 1, 570, 3, 1,700. It's looking pretty good. Let me check this one. So 1 and 570, well, it's not even going through that point. So that one's not right either. All right, we have our answer. All right, so number 5. I think y'all are getting better at this constant thing. So the graph below represents the total number of seeds, seed packets used in a garden. Based on it, what is the constant? So guys, what are we finding? Right? We're finding K. K equals Y over X. So again, it's a constant problem. So we're making a table. So this is my x-axis, right? So I'm going to go and I'm going to choose points where it intersects perfectly. I see it intersects at 2. I see it intersects at 4. And it's here at my origin. So you always start from the left on the graph and go to the right. So I have 0, 0. I have 2, 36. And I have 4, 72. So it doesn't matter which point I choose, right? But I'm not going to choose 0, 0. So here we go. I'm going to do 36 over 2. Going to divide it. 2 goes into 3 one time. 3 minus 2 is 1. 6. 2 times 8 is 16. Bam. Done. So 18 is my constant. Pretty easy. All right, the last one. The Amazon River is one of the longest rivers in the world. It's about 6,400 kilometers long. If 1 mile equals 1.6 kilometers, what is the length in miles? All right, so we're talking about 6,400 kilometers, and they gave us our conversion. 1 mile equals 1.6 kilometers. So guys, this is a conversion problem. So we're going to go ahead and write our word ratio, right? Because we have different units that tells us word ratio. So kilometers and miles. Could we have put miles on top? Yes, right? As long as we're consistent. So I always like to put my conversion factor first. So it says 1 mile equals 1.6 kilometers. So does my 1 mile go on top? No, I have to stay consistent. So 1.6 kilometers over 1 mile is equal to, and we're asking what is the length in miles. So I don't know the miles, but I know that it's 6,400 kilometers. All right, so next step. What do you do next? Cross product, and I always start with my variable. So 1.6x equals 1 times 6,400. So then I need to get x by itself. I'm going to divide both sides by 1.6 so I can cancel here. All right, let me go ahead and do my division. 6,400 divided by 1.6. Well, if you have a decimal on the outside, oops. You have to move it one place, so you have to do the same on the inside, right? So I'm going to move it up. All right, so 16 goes into 60. Well, it's close to 20, and 20 goes in 3 times, so I'm going to try that. That's only 48. Let me try again. 64, perfect. So 4 times 16 is 64, and I have 0. So is my answer 4? No, because there's the decimal's way over here. Is it 40? No. 400? No. 4,000. So make sure that you're working with your decimal. Now then, when you grid it in, I want you guys to start at the decimal and look to the left. So I have my decimal here. So I have 1 0. I have 2 zeros, I have 3 zeros, and then my 4. So making sure it's 4,000. Is it positive or negative? Positive. Grid in my positive. And then make sure you grid in each number. So 4, 0, 0, and 0. Does it matter the ones after the decimal? No. All right, make sure that you have all of your corrections on here. And hopefully you're feeling good and ready for our test tomorrow and your common assessment. Good luck, guys.